union. And the RODO system is to evaluate and analyze the consequences of nuclear accidents, very rightly. And also the Argo system. Has everyone heard of the Argo system? Obviously not. Or RODO system? Yeah, few. Okay. This has been, or this is applied in many countries of Europe. And the part which looks at the calculation of the doses and the calculation of the activity in food products is done by this model. This is an Excel version of this model. This has then been, or was also included in larger computer codes. But what we can show here is the difference on the date of deposition. And I would like to focus a little bit on that, to show you a few examples what the date, which difference the date makes. Okay, we can here select a lot of nuclides, but I would say we start with cesium-137. And we have...
You didn't agree, you didn't change the...
Yeah. Yes, sorry. Okay. The date, I mean, we can choose any date. Let's take a date which is in beginning, maybe 1st of March, late winter. I must say, the underlying data for that, this is for Germany. Germany has a temperate climate. Growth starts mid-March and finishes end of October. It might be comparable to some areas of Japan, maybe more the northern part of Japan. So these are details which have to be taken into account if you look at a particular place. But let's just focus on the principle. We have deposition at the end of the winter. And to make it easier, let's look at wet deposition, and we continue with this 10,000. And here we have to give a amount of rainfall. I start with 10 millimeters. Okay, now I start the calculation. Okay, it's already done. Okay, and then we have a number of quantities which are correlated. First is a deposition. What you see here, I mean, dry deposition is 0 because we said it's 0. We have only rain. This is the interception factor. Grass is a permanent crop. We have a very small interception. It is less than 1%. We have winter barley which stays over the winter. So everything is, crops are not very much affected. And here we have the total deposition on the plants, which is about, for some, about 50. Okay? And if you look at the doses, one step further, we have the total dose, the ingestion, inhalation, cloud shine, activity from the ground, what we discussed before, and then also skin and clothes. And what we see here is this is the dose over 1 week, 1 day, 1 week, 2 weeks, 2 years, 50 years. And we see the concentration or the activity, the pathway following the deposition of radionuclides to the soil and external exposure is slowly growing, and it is by far the dominating pathway. All others are minor importance. Also ingestion, because the food is only is not very much affected. Activities and foodstuffs. If activities and foodstuffs, we have here a number of food items: spring wheat, farro, spring wheat, different whole wheat, flour, bran, are low. This is about below 1 becquerel per kilogram. Okay, now, so we have seen 1st of March, dominating pathway is external exposure, and food is, contamination food is below 1 becquerel. So let's now switch, let's now switch, let's say 3 months later, which is 1st of June. Okay, now I calculate. Okay, again, deposition. Okay. Again, we have the interception, which is here. The wet deposition is here, and the total deposition is about 10,000 becquerel per kilogram. And if you look now at the doses, now it's a bit different. The same pathway, the same time steps for looking at the dose. 1 day, 70 years. Ingestion and exposure from the ground. So, provided that people would eat the food which has contaminated there, now it's different. Ingestion starts immediately, and on the long term, it is about as important as the activity, as the consummate. It is on the long term. It is similarly important as the external exposure. And if we look to the foodstuffs, then the activities of foodstuffs are much higher. For example, wheat has in the first year some 100 becquerel per kilogram, in the following year a bit less, considerably less, about 1 becquerel per kilogram. So the message is, in this case, if the deposition is later, people really live on their own produce, activity, ingestion, and external exposure may be equally important. However, this is a message, but if you look back for Fukushima, I remember in the very beginning some foodstuffs were affected, for example, as leafy vegetables or vegetables which were grown very early. These foodstuffs, they were not consumed because immediately a food monitoring program was initiated to measure the food and also then to withdraw the food as necessary. So this gives you more the potential of exposure. See what could happen if no countermeasures are applied. So, okay, we have to let me. Okay, and then since we have now okay, now we had an amount of rainfall of 10 millimeter. If you go to 1 millimeter, one millimeter means interception is higher and the initial deposition is higher and activity in foodstuffs are higher. Comes up, this is then several thousand spectral, much higher, depending or indicating the importance of the interaction between plant growth, interception and rainfall. And if you will look here at the doses, then for a deposition event with a high difference factor, ingestion would be much more important than activity on the ground, provided that no countermeasures would be taken. Of course, this food would be currently, initially the limits for food in Japan have been 500 becquerel per kilogram, which then dropped to 100 becquerel per kilogram a year later. So much of this food would have been immediately withdrawn from the market. Would have been immediately withdrawn from the market and replaced by uncontaminated food from other areas. But insofar these results from the doses doesn't give absolute numbers, but they show you also if you combine these combine such results with results about the deposition pattern, it shows you which part of a region or an area is affected and how much food would be affected and would be needed to be withdrawn. Okay, then we could make another example. Maybe we go again 3 months later. This is September. In September, usually, or many crops are already harvested. The main season, the most productive season is over. Of course, we still have vegetables, we have leafed vegetables, but the grain has been harvested, etc. So it's a bit different. And if we look at that, go for the deposition. In some crops it's still high, for grass or for grain. For this particular case, cereals have already been harvested, so it's no longer contaminated. And if we look at the doses, okay, ingestion is still important, but less compared to the deposition on 1st of September. And I mean, the message from that is these are examples. This is not necessarily, or this model do not necessarily provide the reality. However, they give very valuable information what is important for the analysis of a deposition. Of course, it shows the dependence on the season. It shows you the different importance of the different pathways. It shows the importance of the deposition mode, whether it's dry deposition or wet deposition, whether you have light rainfall or heavy rainfall. And by the end of the day, it also shows you which areas might really be affected and require additional countermeasures to further mitigate radiological consequences. So this is more a planning tool, a tool for exploring and identifying the important parameters and the important issues. What I have shown here, these elements, this is a deterministic model. So this means it doesn't necessarily address the uncertainties within all these elements with regard to the assumptions and the scenario and the variability of the parameters and the uncertainty of the parameters. But what you can do is you can always look at different specific conditions and check what is the influence and the implication of specific measures. Maybe we have time for one last example. We could go again 3 months later, and this is in December. December, usually all the vegetation is dormant or is not existing because the soil is bare. So we have some deposition on winter barley, on the winter cereals, because they are sown in September, October. We have some vegetables which also grow in winter. The consumption rate of that is very low. And we have a little bit of grass, but the grass is also very tiny, can hardly be used. And if you look now on the doses, on the exposure to people, on the long-term exposure to the ground is by far dominating. So, do you have any question? I mean, we could play here for hours and try all the different combinations of parameters, of deposition dates of rainfall, of dry deposition, of wet deposition, of eating or non-eating something. Because in principle, what is done here, and what is also done in maybe in what is done here, which is also done in rotors and such kind of things, you can now start modifying different parameters. For example, the storage time for food products, which has a delaying effect. If you store food, it's not so much important for cesium, but it's very important for iodine. The consumption rates. So we have here also kind of, we call it import factor. This gives which fraction of the food is produced locally. Here it's 1. It means all the food consumed is produced locally, but you could put here any number. You could put cesium 0 and check what is the implication for the results. Or you could also introduce specific restrictions for food consumption. For example, for milk, there's no restriction, but you could introduce after 1 day, you stop drinking milk for 50 days, for 100 days, and then you see what is the effect in terms of exposure to people. I was too. Hang on. Yeah. This is the seasonality of food consumption. I mean, some food is eaten more or less at similar levels during the whole year. Others, you have a seasonal. I mean, you eat the peaches when the peaches are on the market. You cannot store the peaches to Christmas or to winter. So these things can also be varied. And also important for the dose is, for example, we call it locations, to account for the shielding of different buildings and houses. There you can look where are people staying, whether they are outdoors or indoors, whether you have small houses, single family house, or large buildings, or you're on the stable. So depending on that, these are all things which modify the exposures. Yeah. So about the feeding of animals, these are all details which require some consideration. And if you go for cesium, these are all dosimetric factors, like what is the amount, what is the dose per unit intake for ingestion, for inhalation, different organs, different age groups. And one final thing, the shielding factors are here. Shielding, what is the attenuation of the radiation from different places, indoors, for single houses, or for large buildings. So it makes quite a big difference for that. So by the end of the day, this is a tool to wouldn't say to play, but to you can systematically explore the importance of processes in parameters, to come up with a sound and reasonable evaluation of radiological implications of radionuclide depositions. So, any question? Please.
Okay, just this Excel sheet is a part of lot of system or
Yes, yeah. I mean, not the Excel sheet as such, but the underlying models and parameters is within RODOS. This originally has been developed for Germany. It is applied in many other countries, and many of these countries adopted it to their own radiological and environmental conditions in adapting the growing seasons, the feeding rates, everything, the shielding factors. This can all be done, and it has also, for example, been applied in Hong Kong or in Korea or in, I think, Brazil, because by the end of the day, all these different scenarios and conditions are reflected by specific parameters in such models.
okay, so it is open to public, I mean, internet or
No, this one, I mean, in principle, RODOS is public. RODOS is public, and so it can be, but it requires just a registration with Karlsruhe, with the Karlsruhe Institute for Technology. But in principle, it's free. So, any other question? Maybe you are now tired. Tomo is talking, so I thank you very much. Yeah, please.
My question is so general one for IAEA. Was one of the things with which we can be so familiar with IAEA is the standard sample for spectrometry. So we use some outer samples for gamma spectrometry, and if I understand correctly, you collect some samples and you measure by yourself in the facility by IAEA. Then you provide those samples for different institutes.
Yeah. I mean, not me, but IAEA in general provides reference materials and also organizes comparisons between different laboratories to ensure a high quality of the measurement results. Yeah. Thank you for this. I will bring this message to the people who are doing this work.